Traditionally, people have used Wi-Fi as a locating system based on RSSI, which, if you like, is the first generation of Wi-Fi positioning. There's been a progression of standards from 11MC to 11AC, which are designed from the ground up and have increasing accuracy and capabilities, including security and privacy. So we believe that the new standards are going to be the perfect solution for indoor location.
Hey, this is Martha DeGrasse here again for Wi-Fi Alliance, and this is The Signal, our podcast, where we give you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. And we are super excited in this episode to learn more about Wi-Fi location. We've got Jonathan Segev. He is Senior Wireless Standards Engineer at Intel, and Roy Want, Senior Research Scientist at Google. Jonathan and Roy, welcome to The Signal.
Thank you.
Thank you.
Okay, great. Let's start with a brief overview of your respective roles. Jonathan, let's start with you.
And thank you for having us on The Signal for a talk about Wi-Fi location. I'm a Senior Wireless Research Engineer for Intel. I've been involved in various wireless communication technologies for more than 20 years now. Started with 2G and 3G cellular to WiMAX, and for the last 14 years, been involved with Wi-Fi and IEEE 802.11. I'm currently chair of TG BK 320 MHz positioning, which maybe we can talk about later, and previously chair of TG AZ next generation positioning. And I was also heavily involved in the development of the fine timing measurement protocol, the basis for Wi-Fi location from the very early stages. Roy, over to you.
I work in Android's precision location team, working on Wi-Fi based positioning. In a nutshell, our team puts the blue dot on Google Maps. I'm also the technical editor for the IEEE 802.11az standard, which has recently been published, and the new H211 BK standard during development.
I think you have a few patents in this area, like maybe 100?
Yes, that's right. One of the nature, I guess, of being a research scientist, we file a lot of patents.
All right, excellent. Okay, well, Jonathan, we are going to start with you since you were heavily involved in the development of fine timing measurement. As I understand it, this is a way to measure location, usually indoors, based more on signal speed than signal strength. I'm sure you can explain a lot more about it, but if you could start off with an introduction to fine timing measurement and Wi-Fi location in general, I think that would be super helpful.
So yes, and maybe we can even take a step back and look at the evolution of Wi-Fi location. And what it really started off from is, as you mentioned, RSSI, or radio signal strength indicator-based measurement. This is what we many times refer to as the first generation Wi-Fi location. It was cheap, it was non-standard because it used beacons for the most of the time, and it assumed a very simplistic path model propagation loss for distance measurement. It didn't consider things like antenna pattern, didn't and couldn't multipath and frequency selective interference. And because it didn't consider those, and those greatly affect the RSSI measurement, it resulted in greatly inaccurate protocol or measurement, and as a consequence, impeached the user experience. Then came second generation Wi-Fi location, which is RevMC FTM. So as you mentioned, fine timing measurement, which was the first specifically designed from the ground up protocol for location and range measurement. FTM is a protocol for radio signal propagation time measurement. And by converting the propagation time to range by multiplying by the speed of light, we get a range or a distance. And we're able to pinpoint the device, and we called it RevMC FTM protocol. So that was the second generation that we have today in the market. When Wi-Fi 6 came along, we initiated the 802.11az project within the IEEE. That's many times referred to as the third generation. It brings greater accuracy because via the introduction of multiple in, multiple out, so MIMO, we had larger bandwidth for usages like indoor navigation. And that was hand in hand with the introduction of Wi-Fi 6E. And the enterprise deployments can now use 80 megahertz frequency planning. And with features, additional features like the MAC and PHY security coming as a response to market demand. And what we now have in our evolutionary stages in terms of protocol development, we still don't have it in devices, is already, we're looking forward into what Wi-Fi 7 brought with 320 megahertz wide channelization. And the idea there is within the IEEE, this is TGBK, and the idea there is to take advantage of that and to get to 0.1 meter level accuracies. Roy, would you like to give a bit of a description of how's the market been doing in terms of penetration?
Yes. So this is something that we're particularly excited about. Since 2018, we produced the API for H211MC, so that was available on Android P for all Android phones, but in particular, the Pixel phones, right from the beginning, supported 11MC, supported the protocol. And we began encouraging the other vendors, the big vendors like Samsung, Xiaomi, LG, and so on. And now when we look at our analytics, we see that there are over 2,000 models of phone which supports MC, or which is a great base. Now, the limiting factor really has been on the access point side. So this has been slower development. Since 2019, all of our Google Wi-Fi access points that we sell into the consumer market have supported 11MC, so that makes a great basis for the technology to be experimented with. But now, in the last year or so, we've seen the exciting development of enterprise AP vendors supporting the technology. The most notable which is HPE with their announcement of the Open Locate product and enabling basic FTM, and also LCI, where the actual access points can advertise the position within the locating environment. This is great news, and from now on, I think we're going to continue to see an acceleration and further development of this technology.
Great. Now, what do you think is driving those enterprise APs? Are there new applications emerging that enterprises see value in?
On the application front, the sort of the go-to application which everybody reaches for is indoor navigation. So finding conference rooms, finding somebody in a particular desk. In our buildings, they're often quite complicated. Desks are in open plan areas and so on. So indoor navigation is something which is very important to improve work practice. In the retail environment, there's another level of trying to find products. Imagine you're in a big hardware store. There are just thousands and thousands of products, and trying to find some small product on a shelf can be supported by indoor navigation. That's another area which we think will have a big impact. Also, in, say, something like a grocery store, people usually have shopping lists. You can imagine the shopping list be all electronic. You prepared it before, and then the application guides you around the store to the exact place on the shelves, minimizing
so no more
time.
doubling back.
No more doubling back, and also if things move, hopefully they would automatically update the databases so that you'd find the right place. There are other things I can talk about. Well, briefly, I'll mention inventory management, although I think that's a larger conversation. Also, with the new protocols, we're talking about adding security to the ranging capabilities so that we can also think about this being used to unlock doors when you're within a certain distance. So not just positioning, but also proximity. So how far you're away from something in order to access it or open it. And also this ties back into enterprise, because so often there are documents which are sensitive. Perhaps they might contain social security records, something of this kind. And you only want those documents to be opened in a certain place in a protected area.
Oh,
so that's another area that we might see this.
So, I'm sorry, go ahead.
I was just going to say another exciting area is the home. We think about the Internet of Things as being an area which is growing within the home. And with all these wonderful smart speakers, we can say things like turn on the lights. But of course, in the human way that we say things, we're often very imprecise. So there may be several lights, or which light? Well, the most likely one is the one closest to you. So we can use proximity to disambiguate and do the right thing under those circumstances.
Very smart. Okay, so some of these sound like brand new scenarios, and others sound like scenarios in which Wi-Fi location would be supplementing or even replacing another existing technology. Are there any other use cases where you see Wi-Fi location maybe coming in and doing a better job than the existing technology?
So yes, you mentioned already today, we see indoor location penetrating. Roy mentioned inventory management, the inventory management segment, and we also briefly discussed proximity usages. In the proximity usages today, you have to use passwords to unlock your computer. You have to use your car key fobs to unlock your car. Those kind of use cases, lock your computer as you walk into its vicinity, using your smartphone or using your wearable. We're seeing usages like keyless entry and engine start, and venue access, for example, to a secure ATM premises, right? After hours, simply use your phone for that or your wearable, and you get access instead of doing a more elaborate exercise like taking out your wallet, taking out the credit card or the debit and activate the lock, unlock. That's called venue access. So those kind of usages, essentially, we are seeing Wi-Fi location comes in and penetrating into those segments. If you think of it, there's kind of two methods or two perceptions of how you do location or connectivity location. One method is let's do location and let's develop a radio that is a dedicated radio. It has its own advantages because you can design a technology that is specifically tailored and optimized for that. On the other hand, and that's why what Wi-Fi is doing is taking the already ubiquitous existing service and trying to add another service, which is the location service on top of that. And there's a huge benefit of doing so. One is that you're using the same roadmap development technology as that. You're reusing the same spectrum. You don't need to make sure that the regulators in different regulatory domains are making sure or are seeing the economical value coming from the system because you're part of a larger system. It does have its own drawbacks because you need to come into the standard development and work from within those already existing agreements, access mechanisms, and so on. But again, it brings its own huge benefit. With that, what we're seeing is Wi-Fi location. It might take it a little longer, but it can penetrate and it's there for the longer run.
Okay, makes sense. Now, one of the most important things to locate is a person who needs help. And I know some states have looked at E911 location mandates. Roy, can you give us a little bit of an update on where that stands and how Wi-Fi location can help here?
Yes, and this is one of the most important uses of Wi-Fi location. At present, the FCC have mandated that cell phones, when you make an emergency call, can be located within 3 meters in the vertical direction, so in other words, trying to determine which floor you're on, and 50 meters at the 80th percentile, so in terms of sort of probability of you being found within 50 meters. Now, the way this is done is typically would be from a cellular perspective, using the signal strength of the cell tower and trying to triangulate using that basis. But it's not that accurate. And so in recent years, the smartphone companies like Android have been involved and are using their own capabilities for determining position to augment the basic capability of positioning. And as a result, they've been able to create a far more accurate estimate of where you are. If you're near a window, clearly you can see GPS, and so GPS can be used, but obviously you're often deep in a building, so that's not possible. We've used Wi-Fi signal strength as the basis for determining this position in combination with other things like cellular. But the great opportunity is as this technology rolls out to more and more locations and to more and more products, that we can get this 50 meters perhaps down to within, given the constraints of buildings and so on, perhaps within 10 meters or 5 meters perhaps, and really take the emergency people directly from wherever they appear in your building to where you really are in the building. And obviously this would save lives and get people to hospital faster. So I think that it's very important. And with the AZ technology rolling out, I think that the accuracy will improve and we'll be able to do even better in this respect.
That is exciting. What kind of distance ranges are you seeing now from this technology?
When we talk about distance, we can range typically over maybe as much as 30 meters. The accuracy is the important thing here, of course, and the accuracy that we expect at the, what we call, again, talking about in terms of probability, the 50th percentile, we can get about a 1 meter accuracy, and at the 90th percentile, we can get 2 meters of accuracy with the 11MC protocol. Now, this is going to get even better with AZ in our interop testing. So this is sort of in an office type environment, but it's between vendors. We've seen 0.16 meters at the 50th percentile and zero point 0.4 meters at the 90th percentile, which is a marked improvement over the 11MC technology. This is, by the way, at 80 megahertz. The bandwidth obviously has a big impact on the accuracy here. And as Jonathan said, this is primarily due to the fact that the 11AZ technology uses MIMO. So we've got multiple antennas, more diversity, and so there are more paths which the signal travels over between the various antennas. And we can use all that information, optimize it, and find the first path, which is the thing which allows us to constrain the accuracy with that technology. There are other tricks that we also play in the design. So we have something called the LTF, or the long training field, at the front of a packet, prefix of the packet. And we actually put repetitions in there. So we get multiple estimates of the channel state, which we can then use to optimize the time of arrival. So that also contributes, or can contribute, to the accuracy of the estimation.
Okay, great. Thanks a lot. That's awesome. Okay, Jonathan, you talked a little earlier about your work with the 320 megahertz positioning project in IEEE. Can you give us a little bit more detail there?
Yes. So yes, sure. Very much like in 11AZ, what we did was adapting Wi-Fi location to mainstream Wi-Fi 6. What we wanted to do with the TGBK project is adapting location and proximity services to Wi-Fi 7. And specifically to the 320 megahertz channelization it introduces, along with other properties like the file level security and MAC level security already part of AZ. Essentially, this is what TGBK is about, is the next level of accuracy. Many of those usages that it's targeting would be around the secured proximity, as we mentioned before. It is expected to complete around the same time frame as the IEEE 802.11be, which is the basis for Wi-Fi 7.
Okay, excellent. Now, one use case that we haven't talked about is indoor access points using Wi-Fi location to share their position with automated frequency coordination. That's the system that helps the Wi-Fi 6E devices share the frequency with incumbents. So obviously important that the devices can be located. Roy, can you give us a little bit of an update on how important this use case is in the overall scheme of things for Wi-Fi location?
Yes, it's extremely important. And so we give you a little bit of the background. In determining position, obviously we need to calculate the range from, or the distance from the phone to an access point. But that's only half of the story, because we also need to know the position of the access point. So typically you trilaterate, so you may get three ranges, and then it's basically a mathematical operation which allows you to use those three ranges or more, and the positions of the access points to give you that position, which we often express in a lat long, so it's easily transferable to a map space system. Now, if the access point has that information, it can then provide that to us. The question is, how does the access point get that information? It's a fair amount of work for, I think, the access point vendors to figure out where the thing is and put that information in there. With the advent of the 6 gigahertz band and AFC, they're motivated for more than just location to do it. They're motivated in order to be able to run their APs most efficiently. So,
okay, so there's a business imperative.
There's a business imperative there.
Perfect.
And I think location will be a business imperative in the future, but there's a chicken and egg problem here. So you need to actually make it available, then it becomes more useful and so on. This is the cool thing. So some companies like HPE have created a product called OpenLocate, which some of these APs will be near a window, say, and they can see GPS satellites, so they can figure out their position. Then the access points will range to each other, and based on those anchor points, we'll figure out the position of every access point within the mesh of ranges which they've created through the building, which is quite extraordinary. They will know what their position is, which will then support AFC. But in addition, they can also advertise it using the LCI protocol, which is part of 11MC and 11AZ, and basically express their lat long directly to the phone. So the phone can receive that and use it. And so this is a win-win for both the regulation side and also for the positioning and the location side.
Okay, great.
And then,
go ahead.
I was going to say, and I think Jonathan has another perspective on this as well.
Right. So I think what's unique about the AFC system and the implementation of FDM as part of it is that we're seeing location no longer as merely a service that the communication provides to the upper layers, but a service that the communication layer itself takes advantage of. We mentioned how important is the regulatory side of things and spectrum availability. Essentially, location is now enabling spectrum, right? Availability, that's what AFC means with the introduction of systems like the Open Locate from Aruba. And with regards to that, it enables things that other technologies are struggling with, which is transmit power, because if you're indoor, you can take advantage of the signal decay because of the building. And so you can transmit at a higher power. Your link budget is improving, your range is improving, your accuracy is improving because you're at a better SNR point than you would have if you would be limited to similar systems like competing technology are limited with. One of the things that we see is that what's the most important property of any wireless technology? Spectrum availability. It doesn't matter how you do things, as long as you don't have a place or you do have a place to do those, you're able to communicate. If you don't have the spectrum, there's 0 bits per second that you can transfer, right? With that, so that's one thing with the AFC. The other things is that the Open Locate from Aruba, and we expect other vendors to have similar technologies as well, it greatly reduces the cost, the ops of deploying located network. Whereas previously you have to manually measure location of access points in order to make those available for the use of the mobile devices. Now it's all automatically, and as Roy mentioned, reusing the AFC system requirements. So yeah, that's a huge advantage to ops.
Okay, good. I hear mostly about AFC for outdoor access points in Wi-Fi 6E that need to use more range. Are there going to be a lot of indoor access points that are going to need to use AFC?
Yes, AFC is essentially or started off from outdoors, but it's not only outdoors, because when you're indoors, your improved link budget, because you're able to transmit at a higher transmit power, allows you to also transmit at a higher modulation. Higher modulation means shorter over-the-air time for data transmission, means your capacity just increased by a substantial amount, because now you can, instead of using 256 QAM, you can use a much higher QAM.
Okay, all right, good. Okay, Roy, let's talk a little bit about the consumer angle. Do you think consumers will have control over when, where, and how their location information is shared over Wi-Fi?
For Android phones, we take privacy very seriously. Users will always be in control of their location data. The Wi-Fi infrastructure will not receive ranging location information from the Android phone. And we can also tell you that, as you would have experience when you install applications, the application runtime framework will allow you to define when location information is used. And I think Jonathan has a perspective from the protocol design on this as well.
Right. From the protocol perspective, the group was very much aware of the sensitivity of privacy and the ability for the user to execute a policy that it desires. From that perspective, the group went to a great length to verify that the user is in full control of its location information, and that the user can also manage and choose which information is provided at what time. Also, it's also dependent on the specific use case in mind and the policy that the user would like to execute at this point in time, and being able to opt in or opt out of the service in a way that is available for the user to decide on.
All right, fair enough. What about persistence? Do you think some apps that consumers opt into will continue to track their movements unless they opt out? Roy, you want to stake that one?
Well, I think this comes down to how you enable the app. So you'll be given questions when you install the app as to whether the location information can be used while the app is in use or in the background. And obviously, I would always choose while in use.
Okay. All right, great. Well, this has been great. Do either one of you have anything else that you want to be sure to share while you're here?
I would just like to re-emphasize one of the points that we made earlier, and that traditionally people have used Wi-Fi as a locating system based on RSSI, which if you like is the first generation of Wi-Fi positioning. And as Jonathan said, there's been a progression of standards from 11MC to 11AC, which are designed from the ground up and have increasing accuracy and capabilities, including security and privacy. So we believe that the new standards are going to be the perfect solution for indoor location.
All right, thank you very much. Roy Want, Senior Research Scientist at Google, thank you very much for being here on The Signal.
Thank you very much.
And Jonathan Segev, Senior Wireless Standards Engineer at Intel, thank you very much for being here.
Thank you, Martha. Thank you for having us.
It was great. We learned a lot. And that is our show for today. Don't forget to check the show notes for more resources, and be sure to follow The Signal on Apple Podcasts, Spotify, Google Podcasts, and Amazon Music. You can get all the latest episodes straight to your device. And for all things Wi-Fi, check out Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse. Thanks for listening, and please join us next time on The Signal.